Good afternoon and welcome to the 21st annual exhibit of hydrogen and fuel cell technologies. We've been here for quite some time discussing new national and international developments. We're going to be going on to Spain in our next talk and discussing with Javier Brey, the CEO of Abengoa Hidrógeno, if I'm pronouncing it correctly, Renewable Hydrogen, Energy Storage, Security and Supply. Please welcome with me Javier Brey.
Hello, Brian. Thank you very much.
Hello. So I was very impressed with your stand, by the way, which is D71 around the corner. You have to drop over and see it. For those who don't know, perhaps you could give us a brief company profile of Abengoa, where you're located and what you do.
Yeah. Abengoa is an engineering company, so it's an EPC company, in fact. The headquarters is in Spain, but it's in more than 80 countries today. We have 24,000 employees around the world working on sustainable energy, water treatment, water desalination, solar power, biofuels, wind power, and so on. So that's Abengoa.
Yeah, and it's quite a large company.
Yeah, it's a large company, approximately 10 billion revenues. And one of the branches, one of subsidiaries is Abengoa Hydrogen. So Abengoa Hydrogen is focused on hydrogen production and fuel cells.
Okay. Now, just to discuss this, I suppose, controversially, Spain has just this wonderful resource, namely the sun. Everyone knows it who goes there. And yet, the fates being what they will, you import a large quantity of energy.
Absolutely. Nowadays, we are importing 98% of the fuel that we need for transportation. And this is enormous. That means that if we are not able to pay that invoice, or if we are not able to import this oil because of, let's say, political reasons, then we have to stop our transportation. We have to stop our industry. We have to stop the country. So security of the supply is something that is crucial for us.
And how do you go about addressing that issue? Obviously, we can't simply always rely on the infrastructure outside the country's borders. And this issue is very, very important for Germany. We realize with the tensions between various countries, Russia being one of them, that we cannot simply say, somehow we'll get by. It's a huge risk for an industrial nation. What is Spain going to do about this?
Well, you have mentioned this first point, which is the security of the supply. The second point, the second important point from my point of view, could be the economical aspect. We have to pay almost 30 billion euro per year in order to buy this oil, and this is an amount of money that sometimes we don't have. We have to borrow, so we have to pay the invoice, we have to pay the money, we have to pay also the interests. And taking that into account and taking also the environmental aspects, in our opinion, looking into renewable hydrogen could be a solution. Looking into the possibility to produce a local, renewable, sustainable fuel in order to change from fossil fuels to this new energy carrier.
Okay, so addressing this issue involves the technologies, it involves being able to store energy, and it involves the issue of how you produce renewable energy if there are not resources in the ground in Spain. So are there resources in the ground in Spain, or do you want to go towards renewable energy?
Well, we don't have oil, we don't have almost natural gas. So the short answer is yes, we should look into renewable in order to produce local hydrogen in Spain. And in our opinion, technology is mature enough. Technology is mature enough. Renewable hydrogen is not a chimera, something that we think, okay, it's very nice, but it's not realistic. It is realistic. It's realistic from the technical point of view and also from the economical point of view. Talking about the technical point of view, in Abengoa, for example, we started working on biodiesel or bioethanol reforming 15 years ago. We started our first bioethanol reforming plant to produce hydrogen from ethanol in 2006 with a capacity of 900 kilos per day. So it's an industrial plant in order to demonstrate that the production of renewable hydrogen is possible. Or we are now designing a large biogas reforming plant in order to produce hydrogen from biogas with a estimated production of 10,000 kilos per day. So renewable hydrogen is a real possibility. Also, when you talk about power to gas solutions, it's a reality today, the possibility of put an electrolyzer, a large electrolyzer, in combination with wind farm or a PV plant or inclusive a solar power plant. So the possibility of use PV or wind power to produce hydrogen with electrolyzer is very interesting also. We have seen here several manufacturers of electrolyzers like Proton minutes ago or Giner yesterday talking about the possibility of have megawatt scale stacks, and with those stacks it's really feasible to produce hydrogen in a large plant. And another very interesting technological way to produce hydrogen is using solar thermal processes. Please, could you put the slide? In my company, we have been working with solar thermal power since years ago, since 1978, more or less. And now we have a technology for parabolic throw collectors. This is a 200 megawatt power plant using parabolic throw collectors. The second slide shows CSP, a concentrated solar power plant. So we use the heat from the sun in order to create steam, and we use this steam in a turbine to produce power. This process can be combined with the possibility of producing hydrogen from thermal processes like chemical thermocycles or even water splitting. So we can take the heat from the sun in order to produce hydrogen. Of course, this is the future. This is not today, but in my opinion, there is a long way for renewable hydrogen.
We always distinguish between renewable and non-renewable hydrogen, and I find this an important point simply to make in isolation. Of course, there's other sources of hydrogen. You can get it out of natural gas, but this focus on renewable hydrogen is intimately related with the notion of energy security and self-sustainability within the country. How are steps progressing right now in Spain? It's obvious that the need is there. In the future, this will be an absolute necessity at some point to look at sustainability. Where are you right now nationally, and how are things progressing?
Okay, to be honest, in Spain, we don't have a real concomitance from the government in order to set a strategy for hydrogen. So they are still discussing about how to put that on the table. But to be honest, we have a lot of potential in research centers and in R&D groups. And there are several companies working on that strategy. Of course, nowadays my own company, Abengoa, is not selling in Spain. We are selling abroad, unfortunately. But we have learned a lot about renewables in our own country, and we have the opportunity to test the demo projects in our country before going outside. So Spain is a very good place for renewable hydrogen.
Do you think the market, your own personal market, will start internationally and then return to Spain first? Is that your prediction?
I have to say yes. But I'm not sure if I like this answer or not. But yes, to be honest, that's the situation. And you have mentioned natural gas. In my opinion, there is no good and bad ways to produce hydrogen. In my opinion, if we really want to push hydrogen and fuel cell technologies, we need everything together. We need fossil fuels, we need natural gas, we need renewable hydrogen, we need high temperature fuel cells, low temperature fuel cells. So we have a lot of work to do together if we really want to have a real market in the next years.
You mentioned, of course, at the very beginning that the issue of transportation is important here. And, of course, this raises the question, we can produce hydrogen. What is the status of the vehicles that use the hydrogen? Do you believe that there is already technologies available to allow you, for instance, to do trucking, distribution, logistics with hydrogen and battery-powered vehicles? What about consumer vehicles? There is a mass-produced car approaching. Well, it's serial production in Japan right now. But do you feel comfortable with the status?
I feel absolutely comfortable. In my opinion, fuel cell vehicles are ready in the market. Toyota Mirai is a clear example about that. So, in my opinion, the only thing that we really need is a support from the government in order to have to feel comfortable to create infrastructure, to buy the vehicles and to put everything together. So it's a chicken and egg problem, and we are always the people is always waiting for the infrastructure or the people is waiting for the vehicles. But in my opinion, we need the concomitance of the governments to say, hey, yes, we would like to have hydrogen vehicles on our roads. So, and in my opinion, companies are ready, products are ready. So the only thing that we need to start is a real interest on that.
I should mention that we can take questions from the audience if there are any questions. Just raise your hand and I hope I'll see you. You work also on energy storage. I mean, we started with the mobile applications, but energy is, of course, energy, whether it's mobile or stationary. You also work on power and power to gas. Now, for me, power to gas is a very important technology. What we're talking about is renewable sources such as sun or wind, and their production cycle has nothing to do with the demand cycle. If we're going to use this technology broadly, obviously, we need to be able to store energy. And one of the drawbacks of, for instance, wind energy in Germany is we still haven't figured out how to store this energy. It's phenomenal that they turn off the turbines, the wind turbines. They turn them so that they no longer rotate simply because the grid cannot absorb. Obviously, the grid is old-fashioned in this sense, that the new technologies which are functioning very well don't cooperate with a grid that is basically developed for other energy production. So we need desperately power to gas. We need to be able to convert electrical energy into gas because it can be stored. How are those technologies doing? You work with these technologies. Are you satisfied with the efficiencies? Do they provide a solution for large-scale energy storage? What is your take on that?
We work in both fields, in power to gas and power to power. In power to gas, we have 2 hydrogen filling stations in Spain, in fact, and in both of them we are taking PV power in order to feed electrolyzer to produce the hydrogen, which is a kind of power to gas. And we have also another project in Spain in which we combine hydrogen production with the methanization of the hydrogen in order to produce methane, so renewable natural gas. In this second project, we are working with electrolyzer of 0.5 megawatt. So it's a small project, but it's a good demonstration of the technology. In power to power, we would like to introduce the hydrogen as an energy storage system in our plants, in our solar power plants mainly. So we want to be able to have PV plants or solar power, concentrated solar power plants in which we offer the possibility of a large storage system. We work with electrolyzers and we also work with thermal processes, and we use this hydrogen in a turbine or in a fuel cell. So currently, if in our plants we use batteries, we can storage up a couple of hours of energy. We are talking about 100 to 200 megawatt plants, okay, so large power plants. We use batteries, we can give a couple of hours of storage. We use molten salts, we can offer up to 6 to 8 hours of storage. But if we use hydrogen, we can offer up to 2 days of storage. So with that, you have an absolute flexibility on the operation of your renewable plant in order to be able to follow the demand. So in my opinion, it's quite interesting.
On the issue of power to gas, I have seen this year no discussion whatsoever of how that changes the mobile application potential of, for instance, renewable energy. What I mean by that is we do have a number of hybrid cars. They're not hybrids, actually, they're hydrogen cars. Sometimes they're hydrogen vehicles that combine batteries, but we always had in the past the discussion of the user-friendly auto. They wanted a car basically with a conventional fuel. Conventional fuels will allow you to drive further. Hydrogen has the issue of energy density. We don't care about that issue if it's a stationary application, but if you have a car, you have to think about the size of the tank or how many bars of pressure you need to have in that tank. Now, the question I'm asking is, we started with this issue of 90% of the energy that you use in your transportation infrastructure is imported. The solution could be hydrogen vehicles, but do you also investigate the potential of using hydrogen, adding the CO to it, and making it into a compressed gas that is more easily used in these vehicles because the energy density is simply better? It's like propane, it's like natural gas. Is that another viable option for mobile applications of renewable energy?
In my opinion, nowadays, this natural gas, we need this natural gas for our home and industries. And the hydrogen vehicles are very efficient, very clean, and very silent vehicle. We are going to see how the price of those hydrogen vehicles drops dramatically in order to be able to be competitive with the standard vehicles. And once those vehicles are competitive with standard vehicles or natural gas vehicles, I think that everyone is going to move to the hydrogen vehicle because it's more silent. You also avoid NOx emissions, SOx emissions, or which you are going to have in a vehicle with burning this new synthetic natural gas, and you avoid also the particle emissions in the cities, which is also very important in California, in UK, or in Spain.
It's important in downtown Berlin, where I come from. Several times during the year, particularly in the summer, there's an ozone alarm and a Feinstaub alarm, the dust particles from, and of course in these densely populated areas with a lot of traffic, just the emissions is a drawback by comparison with hydrogen. So I agree with you. This is one of the reasons why the buses are so attractive. Hydrogen buses do not pollute at all. It's been a pleasure talking to you philosophically and also with the technology in mind. I hope you're coming back next year.
Sure, Brian.
Okay, and I would like to tell everyone that your colleague from your company, Africa Castro, will be talking on this stage, there she is, hello, at 12:40 tomorrow. The conversation can continue there, and of course at the booth D71, which is just around the corner here. We've run out of time, but Javier, Brey, it's been a pleasure talking to you. I hope we see you next year.
Brian.
Thank you. And thank you. We'll be continuing in precisely 1 minute. Next up on the stage, we'll be talking to Martin Omer, who's with Fuel Cell Energy Solutions, and they'll be discussing decentralized combined heat and power fuel cells on a large scale. Join us in a minute. Thank you very much.